Hey guys, so this video is basically for use of the debugger in the Mcuxpresso. So basically what we are going to do is we are going to run the FreeRTOS code for Blinky, which we have modified for 3 LEDs. So as you can see right now the code has been running for 3 LEDs, but in case in the future, suppose if I have a long code and I need to use a debugger, so this video will basically tell you what are the basics of the debuggers that we can, the basic tools which we can use from the debuggers. Okay, so in order to get started with the debuggers, as you can see in the quick start panel, okay, over here at the bottom of the screen, I can see that I have a debug tool there. Okay, so debugger project and I have a debugger. But always remember, before starting the debugger, you should always have a debugging probe attached to your target device. Now in our case, we have the USB cord. Now this USB cord will basically translate all the IDE commands which are at the high level to an appropriate low level kind of commands and send it to the target device. So in our case, it is the LPC 1769. Okay, so since I have been connected this, I will start my debugger. Now there are 2 ways to start this debugger. The first way is by clicking onto this debugging tool, and the second way, as you can see in the toolbar, we have 2 debugging elements. Now make sure that we always choose the blue color bug, because the green color bug that is there, if you see, it's a linker kind of a thing, but it will skip the basic of the MCU ID's debugging steps. So better is we start is with this one. So always if you get confused, the best option is you start from here. So once you click on this, you will see that it will give me a debugging probe option. So it's basically loading the .avx file, which is a debugging binary file that has been there. So basically it has not given me that command. Just a moment. So as we see in this case, now it has been, what we have done is we have inserted a breakpoint. One breakpoint is set at this LED. That means when the blue LED is off, it should halt the program, and the second breakpoint is inserted when the green LED is on. So right now we are by default also the breakpoint, if you just execute the debugger, by default the breakpoint will be inserted exactly after the main function. So that's where it has been halted right now. So that's why you can see that there is nothing been going on this board. So basically what I will do is, after this, so this is basically one thing. Now suppose if I want to resume the debugging step, so this is one breakpoint that I have been set. Now in order to go to and jump to my second breakpoint, I will say is resume. So the moment I say resume, you can see the LED flashes now, and now you see the green light, it will just stop over there. So that means, and if you see right now over here, we have a debugging current instruction pointer. That means the debugger is now pointing at this particular location. The next thing would be, if I again start to resume it, you will see that it goes off and it will halt its execution at this point. Now suppose if I said I want a breakpoint over here, so I just need to double click over here and insert a breakpoint. The moment I say resume, so you can see the instruction pointer is at 2 and the blue LED just keeps on glowing. So that's one thing on how to use the debugger. All the debugger tools are basically present in the toolbars. So this is like the resume, this is like suspend the debugging task. If it is executing any kind of a program or something, you can suspend the debugging. This is to terminate any debugging sessions that's ongoing. This is like disconnect from the target device. And this is like step into. So step into basically does what is, it will go into the function. So basically when I press this, you can see it will take me to the board.c file, because the board LED set is present in board.c. So that's where it has taken me over here, and now it will execute, it will break at each and every point and stop over here. So that's what it's going to do. If I again press this, you can see it's going to go in line on the functions. So if I press resume, you can see now I stopped at green. Okay, so it has stopped here. Now if I press step over, so that means it is going to just it's going to skip the function call and go to the next function and stop somewhere. So if I press function call, see the next line, it has halted over there. It has skipped that particular function and it has come and stopped onto the next line. And then there is a return function. So this return function is basically, it will keep on moving in the backward direction. So basically if you see, like we have this AVX file and there is a thread 1 LED task 2, and now when I press this return, you will see it is gone back from 2 to 3. That means it has jumped in the forward direction, in the backward direction actually. So if I press once again, it is basically now again suspended the task. Once again I go back, so it's now it's returning back to the same function. So this basically, the return function will come back to it will keep on looping in the same function itself and not move anywhere else. Okay, now in another way, I wanted to show is the peripherals. So these are basically all the peripherals that are attached to this hardware. So any of the GPIO pins, if it is programmed to be read write pins, you can easily see in this description over here. And then there are registers over here, but there are some special kind of registers as well. Each of its descriptions you can always see by in this description section. Basically R13, R14, R15 and the XPSRs, these are basically some reserved kind of registers, and in order to monitor any value of a variable, if you are executing a code and if you want to see whether what is the value of the particular thing, so what I will do right now is that I will insert a for loop in this just to illustrate that we can monitor any variable. So like int I equals 0. First I will terminate this for the purpose, and now I will just write for I will just insert a for loop over here. Then I plus plus, and I won't write anything. It would act as a delay of like 10 seconds, or it's not actually 10 seconds, but approximately or equal to 10 seconds I would say. So what I will do is into this global variables, now I will start the debugger once again. So when my debugger has started, what I'm going to do is I will go into the add new, and since my variable is I will just type I over here and hit enter. So you could see that it shows like error is multiple. So what I will do is I will resume it. It has gone on top of it. So I will get it back over here, and I will say is I will once again terminate it. And I will run once again this app. So basically before starting with that, I'll show you into the registers. You can see like the registers of what kind of values into them, and the moment I say like int I'll just press it. So now as you can see is that I have this I variable that was there with me. The I variable you can see has the value of 177685. This is like normal any general value that was assigned. So the moment I say like resume, and when it goes here, oh sorry, I just forgot is to put and insert a breakpoint at this. I should have inserted a breakpoint, so I again have to just I will clean up the debug once again, and sorry for this, and I will just start the debugging process once again, and in the global variables I will add I. So you can see this is the default value that it's there. So the next thing I will do is I will just go there. So now if you can see the int value I is 0, okay, and when I just increment it, it has to go to the next step now, and it will show me it has multiple errors. So that's what happens. So in this way you can basically monitor any of the global variables if there are, or any local variables if there are any present. You can just insert them over here by saying add new, and you can have them. And if you see the register values, if they are debugging, you can see these values, the ones that are highlighted right now are being used by this process. So I guess that's it from me right now, and that's the debugging process and the debugging features that we have. So I hope it has helped a lot. Thank you.